When one enormous prompt does extraction, reasoning and answering all at once and the answer comes out wrong, you have no idea which part failed. A new open-source framework called MARC splits that work into role-specialized agents with traceable outputs at every step. The target domain is clinical reasoning, but the design problem is one every agent builder has. Here it is, straight from the source. MARC stands for multi-agent reasoning and coordination. Instead of one monolithic call, it coordinates role-specialized agents, one for extraction, one for reasoning, one for generating the answer, one for evaluating it, through deterministic orchestration. Deterministic is the operative word. The control flow between stages is fixed by you, not decided by a model each time it runs. Context moves between stages explicitly, rather than accumulating in one long conversation. Extraction pulls the relevant facts. Reasoning works from exactly what it was handed. The answer agent writes the response and an evaluation agent scores it. Every intermediate output is retained and legible, which is what makes the next part possible. That's the headline capability. Stage-wise failure attribution. In a single prompt system, a fact, the model never pulled out, and a fact, it pulled out, and then reasoned about, badly produce the same symptom, a wrong final answer. With the intermediate outputs kept, you open the extraction trace and see immediately which of those two happened. In a clinical setting, that difference is the entire debugging story. Here's the arithmetic that motivates caring about stages at all. This is an illustration, not a measurement. The paper doesn't publish per stage accuracy, but if 4 stages each succeed independently with probability p, end-to-end success is p to the 4th. Watch what that does to a pipeline that looks fine stage by stage. 90% per stage, which sounds respectable in isolation, is about 66% end-to-end across 4 stages. 95% is 81. The lesson isn't the exact figures, it's that aggregate accuracy tells you almost nothing about where to spend your effort. You need to know which stage is the 90, and that's what the traces give you. The second piece is a module called the decomposer. You describe the task in plain language, and it generates the task-specific prompts for each agent, which is the author's. Answer to manual prompt engineering being the barrier for domain experts. Worth noting the obvious. Generated prompts still need reviewing before anything clinical rides on them. The framework is configured entirely through YAML with no code modifications, and it's model agnostic. The agents aren't pinned to one provider. It supports both API-based deployment and local, CPU-compatible deployment, which matters a lot in hospitals where the data cannot leave the building. Treat this snippet as shape only. Check the repository for the real schema. Be clear about the scope. This is a version 1 framework paper. The contribution is the orchestration design, the traceability, and the accessibility to non-programmers. It is not a clinical outcome study, and nothing here says this is safe to make decisions with. What's genuinely transferable today is the architecture. Fixed stages, explicit context, retained traces. To sum up, MARC replaces the one giant prompt pattern with role-specialized agents wired in a fixed order, keeping every intermediate output so a failure lands on a stage instead of on the whole system. It's YAML-configured, model-agnostic, and runs against an API or locally on CPU. Even if you never touch clinical data, that traceability is the part worth stealing. Subscribe to BirenAI and ship smarter with AI. See you in the next one.